Next-gen communication connectivity. The evolution of communication and connectivity is a remarkable story of human ingenuity and creative problem-solving that has redefined the way society functions. Over the past few decades, digital connectivity has transitioned from a luxury to a necessity, revolutionizing how people, devices, and systems interact. Today, rapid data transmission across vast distances, ultra-low latency, and immense bandwidth have become the benchmarks for new-age networks, all paved by continuous advances in both hardware and software. This technological metamorphosis is transforming industries, reshaping economies, and altering everyday interactions on a scale that was once unfathomable. Increasingly, the focus is not solely on increasing speed, but on creating resilient, adaptive networks that can meet the challenge of an exponentially growing demand for data and connectivity. At the heart of these advances lies the integration of novel technologies that extend beyond the realm of traditional wireless communication. The emergence of higher frequency bands, such as millimeter waves, has enabled networks to achieve unprecedented data throughput. However, deploying these frequencies comes with its own set of challenges, as higher frequency signals are susceptible to environmental interferences and require more densely distributed infrastructure. Engineers have embraced innovative solutions such as dynamic beamforming and massive multiple input, multiple output (MIMO) configurations to mitigate these issues, allowing networks to focus energy where it is needed most and significantly enhance signal quality. The pursuit of these enhancements is not driven by modest upgrades, but by the ambition to create a communication fabric that supports the myriad demands of tomorrow's interconnected world. Simultaneously, the software that governs network behaviors has seen transformative improvements. Machine learning algorithms and artificial intelligence are increasingly integrated into the management and optimization of these networks. These intelligent systems can predict traffic patterns, automatically adjust network parameters in real time, and even preempt potential faults before they escalate into service disruptions. This predictive capability is essential for accommodating applications that demand near-instantaneous responses, such as autonomous driving, remote medical procedures, and real-time industrial automation. By combining smart processing techniques with state-of-the-art hardware, network engineers are crafting communication infrastructures that can learn, adapt, and evolve, ensuring that the systems remain robust and responsive even as user demands fluctuate. The promise of next-generation communication goes far beyond the realms of traditional cellular networks. It is increasingly integrated with the Internet of Things, IoT, where billions of intelligent devices converge. These devices include sensors, household appliances, industrial machines, connected vehicles, and a host of other entities that continuously exchange data. This expansive network, built on shared protocols and real-time data streams, is laying the foundation for smart cities, where everything from traffic management to energy distribution is controlled by an interconnected system. The synergy created by embedding connectivity into everyday objects is revolutionizing urban landscapes and transforming rural areas by enabling remote monitoring and control in areas previously considered impractical for wired infrastructure. This democratization of connectivity has profound implications, as it not only drives commercial innovation but also bridges socio-economic divides by providing underserved regions with access to vital digital resources. In parallel with these developments, the concept of ultra-reliable low-latency communication, URLLC, is forging new paradigms in how humans and machines interact in critical applications. The need for instant communication in fields such as telemedicine, manufacturing, and transportation demands that data packets traverse the network with virtually no delay. To this end, edge computing has emerged as a transformative approach by relocating processing power closer to the data source. By reducing the dependency on distant centralized data centers, edge computing minimizes delays and increases the efficiency and reliability of network responses. This proximity between computational resources and the end user is particularly beneficial in scenarios where every millisecond saved can have life-altering consequences, such as in real-time health monitoring or automated vehicular control systems. Such innovations exemplify how advanced computational methodologies are interwoven with connectivity solutions to redefine what is possible in a data-driven era. Security also occupies a central role in the evolution of next-generation connectivity. As networks become more pervasive and integral to our daily operations, the volume and sensitivity of transmitted data increase dramatically. This surge necessitates a corresponding leap in cybersecurity measures to thwart increasingly sophisticated threats. Encryption, blockchain technology, and decentralized authentication protocols are among the strategies being advanced to secure data flows and maintain the integrity of systems across a distributed network landscape. The challenge lies not only in securing massive quantities of data, but also in ensuring that security protocols operate seamlessly without compromising performance. As cyber threats evolve in complexity, the development and deployment of proactive security frameworks that can adapt in real time have become paramount. These measures are designed to ensure that as connectivity advances, user privacy and data integrity are never relegated to secondary concerns. Economic and environmental sustainability are further considerations that must be balanced with the rapid pace of technological innovation. Deploying cutting-edge infrastructure, such as densely spaced small cells and advanced backhaul systems, invites significant capital expenditures. Nevertheless, the potential for economic growth and increased efficiency can justify these investments. Moreover, engineers are tasked with designing systems that are not only high-performing but also energy-efficient. Innovations aimed at reducing the environmental footprint of network infrastructures include the integration of renewable energy sources, energy harvesting technologies, and advanced battery management systems. The marriage of economic prudence with environmental responsibility ensures that as we push the boundaries of what networks can do, we do not inadvertently accelerate unsustainable practices. This conscientious approach enables a seamless transition toward future technologies that are both profitable and responsible, ensuring long-term viability in a world where resource constraints are increasingly critical. The transformation ushered in by next-generation communication technologies is also reshaping the way people experience media and entertainment. Ultra-high-speed connections and near-zero latency are catalysts for revolutionary experiences in augmented reality, AR, and virtual reality, VR. Immersive environments that seamlessly blend digital content with the physical world become a reality as these advanced networks ensure that visual and auditory data is delivered without delay. For the entertainment industry, this means streaming ultra-high-definition content, supporting interactive gaming, and even enabling remote experiences that feel as engaging as physical presence. The implications extend far beyond leisure, as these technologies facilitate remote collaborative training, virtual tourism, and digital storytelling that harness the power of real-time interaction. What was once confined to the realm of science fiction is rapidly being transformed into tangible, everyday experiences that enrich cultural expression and redefine how we perceive enjoyment and engagement. A critical factor behind these sweeping changes is the global drive towards standardization and interoperability among communication protocols. International bodies, research institutions, and tech conglomerates are continuously working to develop cohesive standards that ensure different systems can communicate effectively despite differences in local infrastructure or technology platforms. This harmonization effort not only expedites technological adoption, but also guarantees a level of reliability and security that is consistent across various regions and industries. As regulatory frameworks evolve to accommodate these advanced systems, the resulting uniformity empowers innovators to develop products and services with global applicability, thus accelerating the diffusion of high-speed connectivity worldwide. The alignment of standards minimizes fragmentation, enabling a smoother, more efficient integration of new technologies into the existing communication ecosystem and ensuring that the benefits of next-generation connectivity are universally accessible. Beyond terrestrial applications, next-generation connectivity also heralds a new era in interplanetary communications. The ambition to extend reliable, high-speed connections beyond Earth is gaining momentum as researchers develop technologies to support deep space missions. Advancements in optical communication systems, which utilize laser-based signals to transmit data over vast distances with minimal loss, indicate that future space networks may soon enable real-time communication between Earth and spacecraft. These groundbreaking systems are designed to overcome the significant delays and signal attenuation typically associated with radio frequency transmissions in space. By exploiting the principles of photon-based data transmission, the potential exists to create a robust network that underpins safe and efficient space exploration, paving the way for interplanetary internet access and even the remote control of extraterrestrial robotic explorers. In this futuristic vision, the concept of connectivity transcends planetary boundaries, embodying the human spirit of discovery and the limitless pursuit of knowledge. The advent of these technologies is accompanied by significant challenges that require coordinated efforts from multiple stakeholders. For instance, managing the spectral efficiency of networks, especially in urban environments dense with devices, demands an intricate balance between power, interference mitigation, and regulatory compliance. The array of challenges includes not only engineering hurdles but also policy-related and ethical considerations that determine how data is shared, monitored, and protected. Industry leaders and policymakers must work in tandem to outline regulations that safeguard public interests while promoting innovation. It is a complex dance where technical capability, economic viability, and societal impact must be continuously calibrated against one another. The success of next-generation connectivity depends on solutions that are not only technically sound but also resilient to real-world complexities, making the interplay between technology and policy an essential ingredient in the final outcome. As these innovations progress, the human element remains central to the narrative. The transformative power of connectivity is ultimately measured by its ability to enhance human experiences, bridge cultural divides, and enable collective progress. Networks that are faster, more reliable, and universally accessible energize communities by providing equal access to information and opportunities, thereby fueling education, healthcare, and economic development. In rural and remote areas, improved connectivity translates directly into the empowerment of communities that historically may have been isolated from the global digital economy. This significant shift in access not only levels the playing field for individuals, but also inspires a creative reckoning in how societies envision the interplay between digital and physical spaces. The road toward universally accessible, intelligent connectivity is laden with technical challenges, yet it is the potential for human improvement and global unity that drives its advancement. The deep interconnection between people and technology is a dynamic feedback loop wherein every technological advance alters social structures just as societal needs prompt the development of new communication paradigms. The success of next-generation connectivity is being measured by its ability to dissolve the barriers that separate people, economies, and cultures. It fosters environments where collaborative innovation can thrive and where the sharing of ideas is unhindered by technological constraints. As data continues to pour in from billions of connected devices, the ability to analyze and act upon this massive influx of information becomes paramount. Real-time data analytics and artificial intelligence not only manage network traffic but also provide insights that can improve the quality of life by optimizing resource allocation, forecasting trends, and even preemptively addressing potential issues before they become critical. In essence, the very fabric of society is being rewoven through this digital interaction, creating admixtures of art, science, and commerce that propel humanity forward with newfound synergy. The transformation spurred by next-generation communication and connectivity is ultimately a testament to human ambition and creativity. It is the product of a long-standing desire to overcome the limitations imposed by physical separation, time, and space. Each breakthrough represents a stepping stone toward a future where communication is instantaneous, immersive, and profoundly personal. The cumulative efforts across hardware design, software development, regulatory standardization, and international cooperation are converging to create networks that are as adaptive as they are powerful. Every innovation, whether in improving the energy efficiency of network components or in enhancing the security protocols that protect our data, is a building block in the edifice of our digital future. In reflecting upon these developments, one sees not only a technological revolution but also a deep cultural shift, one that places connectivity at the core of our collective identity and sets the stage for a future rich with potential. The transformative journey of next-generation connectivity is as much an evolution of societal values as it is a leap in technological capability. The pursuit of faster speeds, greater reliability, and universal access is intertwined with ethical imperatives that call for equitable distribution of resources and responsible stewardship of data. As connectivity becomes more deeply embedded in every facet of life, the responsibilities of designers, engineers, and policymakers grow in tandem. Ensuring that these networks serve the broader good requires a thoughtful approach that harmonizes innovation with accountability, ambition with sustainability, and progress with equity. It is this delicate balancing act, managing the technical, economic, and ethical dimensions, that will ultimately define the success of future communication infrastructures. In the grand scheme of technological evolution, the advent of next-generation connectivity and communication is not merely a cycle of upgrades. It is a reflection of our collective aspiration to transcend physical limitations. As the digital landscape expands into territories once considered unreachable, our understanding of community and collaboration is fundamentally altered. The interplay between scientific breakthroughs and practical applications fosters an environment where new ideas flourish, and every device, sensor, and data packet contributes to a complex tapestry of human interaction. This evolving reality challenges traditional conventions, inspiring thinkers and creators to reimagine every aspect of society, from urban planning and environmental stewardship to artistic expression and democratic governance. In this unfolding narrative of progress, the boundaries between the possible and the imagined blur, leaving behind a trail of remarkable achievements and a future filled with untold potential. Ultimately, as we stand on the cusp of this revolutionary era, the journey toward next-generation communication and connectivity is both exhilarating and challenging. Each new advancement brings with it groundbreaking capabilities and unforeseen dilemmas. The pervasive nature of connectivity means that every moment is an opportunity to witness and shape a future where digital and physical realms blend seamlessly. As we embrace this era, the responsibility falls on every stakeholder: engineers, innovators, policymakers, and users, to harness these advancements in a manner that enriches human life while upholding values of privacy, security, and sustainability. It is a collective imperative to ensure that technological progress is matched by an equally steadfast commitment to human dignity and social equity. Every leap in network performance, every innovation that reduces latency, and every incremental improvement in connectivity is more than a technical achievement. It is a profound statement of our enduring desire to connect, collaborate, and create together. This culmination of hardware ingenuity, smart software design, and global cooperation is redefining our world in real time. The next generation of communication is not simply a faster internet or a more efficient data network. It is an expansive, transformative ecosystem that touches every aspect of our lives, from critical infrastructure and healthcare to entertainment and everyday human interactions. The promise of this technology is an invitation to dream bigger, to build bridges where barriers once existed, and to foster a new era in which every individual, irrespective of geography or circumstance, can participate in the global digital conversation. Each moment spent in this revolution is a vivid reminder that technology, when approached with vision and responsibility, can expand the horizons of what is possible. The relentless innovation in next-generation connectivity paves the way for a future defined by seamless communication, dynamic interactions, and a deeply interconnected global community. As we move toward this horizon, it becomes clear that the ultimate goal is not just the optimization of networks, but the enrichment of human life and the creation of a world where every connection counts. Every breakthrough, every refined protocol, and every engineering triumph adds a new layer to our shared digital universe, inviting us to continuously explore, adapt, and grow together. Each moment spent within this revolutionary era is a precious opportunity to witness and shape a future where communication is not confined by traditional limitations but is an ever-expanding horizon, inviting us to dream bigger, reach further, and connect more deeply than ever before.